Do you have a duster? Okay. Good morning. First of all, thank you for accepting my apologies. I don't know if you accepted. At least I saw some few who acknowledged. You know, it's good manners to communicate. But apologies for the delay. Now, we have so far covered topic 1, which is about sets. Okay. And this is topic 2. These are very short, brief topics. Yeah. This is about relations. Possibly we are going to cover this in today's 1 hour, if we can use it well, or if you can be able to understand better. Who is the class rep? You haven't gotten one. Can you devise means to clean this place? Because I don't see the duster. Okay, but I'll need to be able to make some illustrations. Let's get any volunteer, leadership skills. Find ways to make sure the board is clean. Any person want to be blessed? Okay. So we covered sets. We looked at where sets are applied. We have looked at different type of set numbers, from natural, integers, whole numbers, name them. Okay. We also came into appreciate different arithmetic operations on sets, looking at usage of Venn diagrams, okay, to make an illustration of how different sets can interact. And we looked at union sets, how you illustrate them using a Venn diagram. We looked at disjoint sets. We looked at null sets. We looked at intersecting sets. We looked at complements, okay? Then we also looked, say, just like any other properties or mathematics that we looked at, we found that there are different categories of sets. Okay, I think almost over 9 different types of set, from null sets, universal sets, subsets, proper subsets, disjoint sets, name them. Okay, now from those sets, if you did not understand the first part, now relations are still related to sets, but it's another topic. So you're going to have issues. But my assumption is that with the assignments that we gave, I actually gave some assignments, which I hope that you're taking serious to look at. And as I told you, how do we eat the elephant? How did we say we eat the elephant? Somebody says you can't eat an elephant. But later when we reasoned, we found that you can actually eat an elephant. Okay? So when you look at the elephant, you are like scared, this is too big. Somebody will explain. As you tell him, can you eat the elephant? He's touching the elephant and say, but this is too big. Look at my size. You understand what I mean? But when you put strategy, skin the elephant, take the meat, put it in the fridge, eat little by little. By the time you finish the year, the elephant will be inside. Okay? We use that illustration to show you how life plays on our mind. Okay? The major illustration for that was how life plays on our mind and how you have to be very smart. that certain things that look very difficult, if you give them time, surely you are going to win. But some people don't put strategy, they don't give it time, and they think they just want to fall onto things. Unfortunately, the mind cannot accommodate or win things in that manner. Okay? So those assignments, I hope that you have done them. Number two, if you have a problem, we hope that you have used collaboration skills of consulting other people. You don't have to come to me. You understand what I mean? Get a friend, do that work. Okay? As surely as the sun rises and sets, you will find those numbers. Okay? So don't wait to start the conversation, because that's about 2 or 3 weeks from now. You are there, you want marks, I'm very sure, not so. Okay. But those I'm giving you ways to the marks. However, you don't even want to go. Yeah? Those numbers will come and you will see how they look like when you have not tried to befriend. Yeah? But there they are. It is a black check for you to practice and find your way. However, of course, I also know from research that I can bet that because I've not come out with a stick or I've not said I'm going to look at that work, I can be very sure less than half the number of students. Yeah? I'm using facts because I've been teaching for over 15 years. Yeah? I'm very sure that more than half of the class has not done the assignment. But for me, I'll keep on reminding you, because these are tricks of the mind that I need to let you know. So as you go on, you don't revise, go into the next. Yeah? Surely challenges will come as you see them. Have you ever seen problems coming and you are just there standing? Staying in wise, and they tell you water is killing, and you are just there waiting till. Okay? So please take that work serious step by step. Okay? Okay. Now, relations in mathematics. Relations. Okay, what is a relation? What is a relationship? Let's not. What is a relationship? Connectedness. Okay? Connectedness. This is English. Stop first of going. You know, other people, once you talk about mathematics, they start making it very complicated. These are English words. They have carefully been selected. Relation. Okay? So when you talk about a relation, it means that maybe two or more objects have certain things that are similar. Okay? So here, what should come into your mind when we talk about relations here, rather than it going to, now this is a relation of mathematics. We are saying it's relation, it is still related to sets. So we are saying one or two sets have the elements in one or two sets have a way they are related to each other. So you are trying to make an assessment of those relationships that exist between one or two sets. Okay? Let's say, for example, you have set A that consists of course units being done in, not course units, courses that are being done in the Faculty of Science and Technology. So what will that set be? You can have set A, which has BIT, BCS, BSE, and stuff like that. Then you have another set, which is not of the courses, but consists of the type of subjects or units that are being done, which could be discrete mathematics, it could be introduction to computer, it could be, what are you doing? What else are you doing? Computer architecture, name them. So you will list here the different programs, and so set A is a list of programs. Set B is a list of course units. Now, relation will come in when you want to look to study the relationship between the course that is being done and the units that are being offered. So what happens is that you will keep on connecting a particular course to a particular course unit. You will find However much you are in computer science and you are doing BSE, there will be some course units that you are not going to be doing in the other set. So we use relations to study different relationships that may exist between two or more sets. However, what is important in this class now is to go into the jargon, to go into the mathematical representation. That is the only thing that differs. How do we represent these sets, the relation between these sets? And number two, maybe how do we calculate? Then what type of relations exist in sets? So that's ideally what we shall be looking at in this 1 hour. Okay? So as you can see there, that relation in mathematics is defined as the relationship between two sets. Okay, it is two or more sets. Okay? Now, if we're given two sets A and set B, set A has a relation with set B, then each value of set A is related to value of set B through some unique relation. And so every time we always have to define what type of relation that is. So here set A is called the domain of the relation, and set B is called the range of the relation. Do we have? Now, we get some key terms there. Okay. We have something that has not been talked about here. Let's talk about what we call code. Okay. That if you have set A, okay, if you have set A, let's say set A, I don't know whether this set A is equal to set A is equal to 1, 2, 3, 4. And set B is equal to 1, 4, 9, 16. Okay? Now, just from looking at what set A is and what set B is, okay? Is there any relation you can derive from these two? Okay? B, so it means that for you to get value for B, okay? For you to get the value, actually, yes, to get the value for B, you have to square every element in set A. Are we together? So, if you represented, now remember that most of the time, the relations, we represent relations. Because the relationship is, we have A and B. So you are picking pairs of elements. If you want to show the relationship here, you are going to pick, okay, pairs of elements that demonstrate that relationship. So we usually have what we call ordered pairs. So for example, R would be, that's now the relation. This is set A, this is set B, this is R, the relation. So if you want to make representation of the relation, to be able to demonstrate the relation that exists between that, you will say 1, 1, okay? Then you'll have 2, 4, then you'll have 3, 9, then you'll have 4, 16. Okay? Now, this is a description of the relationship that exists between the two. Now, when you look at this, you can find that every time you have an element A, an element in set A, you square it to get the element in set B. Okay? So 2, for you to get the element here, even if I removed it, you just simply need to have 2 square. Okay? So the relationship here is a relationship of y is equal to x squared, okay? And we represent them in that order. Now, there is a concept we are talking about here in terms of domain. There is a concept called domain, codomain, and then relation, and then range, okay? So now, domain, in terms of representation, we have it up there. You will have the elements in the first set, which will be 1, 2, 3, and 4. Okay? So these, the elements in X represent the elements of the domain. Now the elements to which X is related, okay? We call them the codomain. Okay? So here what will we have? 1, 4, 9, 16. Okay? Now, when we try to demonstrate the relationship, you are simply inferring that 1 is related to 1 by square, yes. 2 is related to 4 by, 3 is related to that by, and that is related to 16 by. So there is a relationship between the domain and the codomain. Okay? Now there is something I want to add, that you can have elements in the codomain that sometimes, in quotes, that do not have any relationship with elements in that. Are we together? So for example, let me say, if for example we had more elements here, I think that should confuse. Let me add here, just so that you understand. That the codomain this side had another element called 17. Okay? So the relationship here will not be affected because we still have that relationship existing. However, this element here has no relationship to the elements in that domain. So there is a difference. There are times when we have in the codomain, we have what we call a range. Okay? Because I know you're going to encounter them, and they are small things, but they can become very difficult if you are reading on your own. So when we talk like here now, they are talking about domain and range. They are not talking about the codomain. So now we say that in the codomain, it lists all the elements that are there. In the relation, you're only looking at elements, okay? Images of elements in the codomain, which are related to the elements in the domain. That is the range. Now, codomain consists of all elements you have all the elements, including those that are not necessarily related to the domain. Am I speaking Japanese? You're okay. I'm trying to build for you to be able to see that when you have two sets, it's not automatic that all the elements in set B are related to the elements in set A. Okay? So, where you have all those other elements, you can call that a codomain. Okay? But then, where you have only elements that are strictly related to set A, then you call that a range. So a range is a subset of codomain. So if you can have list of subject units in set B. Okay? But you might have a scenario whereby the subject units you have in the codomain you have microeconomics, you have many social science, something. Now that is still a core domain of subject units being offered at Cavendish University. But if we are relating those subject units to the courses being offered in the Faculty of Science and Technology, certainly we shall find that we have a relation between the course that the students are doing with some elements like discrete math, with some element like computer architecture, with some elements like programming. But there are some elements which are lying idle in these other sets like microeconomics that have no relationship whatsoever to. So that set of elements where you have those related plus those not related, it is called a core domain. But that set of elements of which each element in set A is related to the other is called a range. Okay. So we say relation is defined as the relation between two sets of information. Suppose we are given two sets containing two different values, then a relation defined such that it connects the value of the first set with the value of the second set is called a relation. Suppose we are given a set A that contains the name of girls of a class and another set B that includes the height of the girls, then a relation connects set A with set B. Okay? So in mathematical terms, we say that a set of ordered pairs in a relation. So it's very important that in the representation of a relation, you need to know that it's a representation of ordered pairs. What did we call sets when we defined sets? An ordered, okay? An ordered elements. What are we saying the relationship is? We are saying, one important thing we are saying is that a relationship is a set when you represent the elements in a relation, there must be ordered. So while set is an order, when you talk about the relation, it must be ordered. Because if you are looking at the relation between the courses somebody is doing and the course unit, there is a relationship one way, the course being related to the course unit. But it can't be when you change looking at course units, going to the courses the students are doing, then you are not going to have, that is not the same. So ordered pair means if you have 1, 3, when you make the interchange, it's not actually the same thing. Okay? So let's look at an example there for illustration purpose. Okay? Now, examples of a relation in mathematics include, suppose there are two sets X. What did you use to rub the board, my friend? Volunteer. So suppose you have two sets X. Set X is 4, 36, 49, 50. And set B set X is 4, 36, 49, 50. Is equal to 1 minus 2 minus 6 minus 7 So this is set A, this is set X, and this is set Y. Okay? So if you want to get a relations, you can be able to get a relation between these two sets. Remember, a relation, you can define it. You can actually be able to define a relation and be able to get a pair. For example, you can say a relation where, okay, if I said a relation where x is less than y, if I say a relation where x is less than y, what do you think would be? Huh?
Use the 4 from x is 7 and 6.
A relationship where x is less than y. You will have 4 and 2 y.
4 and 6 and 4 and 7.
Yes. No, we have y here. So these elements here are a subset of y. You understand? This is a y and is a subset of y. You understand? The small individual elements of y. So if I said, I gave a condition of the relationship to be x is less than y, so that you group them. No, x is, okay, sorry, I think x is greater than y. That's what I'm saying. Where x is greater than y. Look at the pair, ordered pair. That is the first principle. Ordered pair. That pair. So what you realize is that you can have some elements which create a relationship. But if, for example, I had another element in this side, which is 70, for example. Okay? Now, where I come and maybe I'm trying to relate, okay, where I'm trying to relate, and I find that the element here is less than the other one, it will not be part of the relation, but it will be part of the set. Okay? Now, if you are smarter enough, you will realize that when we talk about relations, we are looking at a component of elements which are a subset of the Cartesian product. Hey, those who are Muslims will say, how do you say? Inshallah. Those who are Christians should say, hallelujah. Eh? But now, once you are not saying that, I'm not sure. Eh? Do you remember our Cartesian product? That if you have set X and you have a set Y, eh? What will be the number of elements? What will be the cardinality of that set? if you have set A and you have set B, what will be the Cartesian product, or what will be the cardinality of the Cartesian product of that set? Or what will be the power set? All the subsets? How do we get a power set? Okay,
Excuse me, Mr. Evans.
yes.
We cannot see the presentation.
Yeah, we are hearing. Go ahead. Okurut.
Sir, the presentation is not visible to us. I don't know why.
David.
I'm seeing so many people raising up their hands.
Okurut, I can't hear you. I don't know what the problem is.
We cannot see the presentation.
Okay. Okay. Do you remember what the Cartesian product is? Multiplication of all the elements in set A times the elements in set B. How do you represent the Cartesian product? Yeah? Pairs. Okay? Now, when we talk about relationships, we are trying to study the relationship that exists between the Cartesian product pairs. Are we together? So, when you look at the pairs in the Cartesian product, they will have certain similarities of which you can generate a relation to start describing that type of set. That's what we're talking about here. Okay? So when I say X is greater, I'm just bringing out my imagination of the type of relation I want to get out of the Cartesian product of those two sets. Okay? Now, when I will be talking about the different types of relations, like where I say symmetric, when I say inverse, when I say identity, I'll simply be trying to make you to start looking at the data of set numbers there, or the set pairs, and try to see which ones conform to this type of condition. Now, some of them, as you can see, they could be, you can clearly have those examples, but there are some that you can be able to define according to how you want to deal with that data. So this leads you to a problem-solving skill of imagination. Yeah, that you can have data and you want to infer. It's upon you depending on what you want to do. Okay. Okay, so we're saying that we have example of a relation. Hey, you still removed the whatever and you still went and threw back the thing. I want, okay. This is your attendance. Oh, no, but you have this thing on the board there. Okay? So, what we are saying, up there, you can see that suppose we have sets X, which is 4, 36, 49, 50, and Y is 1, minus 2, minus 6, minus 7, 7, 6. A relation R that sets us, relations between X, Y is the relation R, is that there is a relation R if X is a square of Y, can be represented using ordered pairs. Now, you can see that now we start making ordered pairs of X and Y. So you can have 4, you can have a pair 4, then, comma, minus 2. You can have a pair 4, then 2. You can have a pair 36, then minus 6. You can have a pair 36, then 6. You can have a pair 49, then negative 7. You can have a pair 49, then 7. Now, what are we saying? That we are trying to pick elements in set X that are a power, or they are 2 times, or they are not 2 times. They are a square of the elements in, but we are representing them in ordered pairs. So we are trying to get the pairs that correspond. I hope that is clear there. Okay? So we say also the image added below shows 2 sets A and B and the relations between them. We are having set A. I think I've already been able to talk about that. Now, representation of relations. Just like sets, you can represent relations using 2 important ways. One is set builder notation. You remember? Where we use properties. You describe the properties of the set. Yeah? But you can also use the roster notation, where you are able to show all the pairs in that relation. Okay? So let's look here, for example. So if the relation between 2 sets is represented using a logical formula, then this type of representation is called the set builder notation. You describe the properties and you can be able to generate as many of the elements. Somebody can just be able to look at the properties and be able to derive the ordered pairs. Okay? Has this thing of ours refused to work? We are boiling. Yeah? You don't have the... I'm told, yeah, you can still stand and press. Yeah. Power button. Just stand on your chair on the right. Yeah, control it now. Okay. So we have an example there given 2 sets X is equal to 2, 4, 6, and set Y is equal to 4, 8, and 12. Then after observing clearly, we can see that each element of set Y is twice the element of set X. What will the relation be? So where you can be able to make a description. So we are seeing you have R, which is the relation, okay? So we say R is such that You have first of all elements A, B. Where are elements A coming from? Can you give me elements A? Yeah? 2, 4, 6. And B could be element 4, 8, 12. Okay? So we say that, so you represent that in the brace to show that there is a relation which consists of elements, there's some element. This is not capital A and this is not capital B. When we show these small letters, we use them to represent the elements in the sets. So you have set A and you have set B. So you use the small letters to represent the pair, the ordered pair of elements which you are trying to relate. Then you will say, after you have those elements A and B, you are going now to describe the property. Is that B is twice of A. Okay? Is twice of A. Okay? But you add something that A is a subset of capital A. Okay, yeah. X, because you are saying A should be an element, what you are trying to say, the subset, or it should be an element of X, and B should be an element of Y. And then you close. Now, this is the set builder notation. That if I now come to this element and find I have A is equal to 2, 4, 6, 2, 4, 6, and B is equal to 4, 8, 12. Now, what I mean when I say that the relation this AB, where B is twice of A, I will try to look at the Cartesian product of those elements and be able to see whether the pairs, whether the pairs fulfill that condition of A being twice the other one. Okay. Now, roster builder notation. No, roster form. So the roster form is another way of representing a relation. In roster form, we use the ordered pairs to represent the relation. Okay. For example, if we are given two sets, X is 2, 4, 6, Y is 4, 8, 12, then the relation between set X and set Y is represented using a relation R such that R, okay, is equal to, now you put the pairs, okay? So we say 2, 4, okay? We are having 4, 8, and then we are having 6, 12. Now that will be your relation. Again, I want you to note that relations are pairs of elements picked from each of the sets. The sets are individual elements. This is going to eat your head up to. Okay? So you need to be very careful about that. Do we have any question up to that point? Madam, are you worried? Or your mind is completely far away? You know, you can be here, but somebody saying, now I left even that tea. For you are struggling to, I didn't drink that cup of tea. Now, when you have a set A and set B, or a set X and Y, there are also different types of relations, just the same way we had different types of sets. Okay? Number one is an empty relation. Empty or null relation. It is very possible to have set A and set B, and you don't have any element in the relationship. Okay? Now let me say we already have set A and set B. Give us, if I said, write down a set of relations that shows B is less than element A. What would that relation consist? Yeah? What would that consist? What will you have in those pairs? Element B is less than, in terms of the pairs, 4, 6. If you are looking at this point when you're just looking at the pairs at each point, okay? I know it can confuse when you do the categorization, but just where you are looking at the elements here, you might not be able to get. You understand? Because the pairs, each of these is much bigger than the other. Okay? So empty relation. So a relation R on set A is called empty if the set A is an empty set. Any relation where no element of set A is not related to the element of set B, then it's called an empty relation. Okay? For example, where you have set A, it has element 1, 2, 3, and set B has element 5, 6, 7. And you're looking at a relation of xy where x plus y is equal to 22. X plus y is equal to. So you're saying you have A is equal to 1, 2, 3. And B is equal to 5, 6, 7. Now you're saying you're looking at a relationship. Okay? Where AB, no. You're looking at relation XY. Why is it XY? So you're looking at a relationship AB, okay, where A plus B is equal to 22. So you're simply looking at, you have your elements, you know them. You're trying to look at A plus B. 1 plus 5, 2 plus 6, 3 plus that. That's an empty set. Okay? Now, if I change this and say you're looking for the relationship where A is equal to A plus B is equal to 10. Are we together? Okay? If I say that we are looking for a relationship where A plus B is greater than or equal to, is greater than or equal to 8.
2, 6, and 3, 7.
You will have 2, 6,
3, 7.
and then
3, 7.
3, 7. Yes? 1, 7. Wait. 1, 7. 1, 7. No, we are looking just at the subsequent pair of elements. 1, 5 gives you what? You are saying 2, 6 because 2 plus 6 is equal to? Okay, and you're saying 3, that because 3 plus 7 is equal to 10. 1 plus 5 is equal to 6. So that does not qualify. Now, besides empty relation, I mean, I'm just showing you these are small things that they can tweak and they give you problems. So don't just go there and cram numbers because they will twist. We are looking at application. So get the principle, get the concept, because when the numbers come, they will come in a different waveform. Okay? So number 1 is empty set. Number 2 is reflective relation. Reflective relation. Anybody that has just reported this week? Hey. Anyway, previously we used to drag a lot behind, yeah? Now, reflective relation. Reflexive. Okay? So a relation R on set A is called reflexive. If A is a subset of R, holds for every element of A being a subset of A. Okay? So if we have to reflect, it comes from the word reflect. Is reflect the same as reflex? What does it mean? But in this context, I think that is what it means. Yeah? Reflexive. Something that is reflexive. What does that mean? It's like a mirror of itself, right? Okay. So when we are talking about reflexive relation, what comes into your mind? That the pairs, the subset of pairs in that Cartesian product, you go into the Cartesian product of the elements of the pairs, then look for elements where the elements in A appear to be the same elements in. Are we together? So you are looking, actually here use the word mirror because very many of you will understand. That for every copy you have in A, you go and look for only those pairs where for every copy of A, you have the same copy of element in B. So you pick only those pairs. So, for example, we are seeing that you have set A, okay, where you have, we are saying that R, what has happened? It's the same mark I've been using. Okay, AA, BB, okay. So if you had set A is equal to AB, we are saying where set A is equal to AB. Then you are looking at scenarios. It is the same set. If it's reflective, it means that the pairs are actually the same. If you have 1, 1, you have 2, 2, maybe you have 4, 4, the pairs are reflective. So it means that the domain, what is in the codomain, is the same as what is in the domain. Okay? So we are looking, for example, where you have elements, you have here A is equal to 2, 3. Okay? So when you have relation R, it will be the same as pair 2, 2, and then 3, 3. Okay? Reflexive. Okay? Symmetric relation. Symmetric relation. Symmetric. Symmetric relation. So a relation R on set A is called symmetric if BA, if relationship BA so where you are saying you have pairs BA is a subset of the relation. Holes where AB is also a subset of R. Okay? Then relation R AB BA is a reflective relation. I mean, is a symmetric relation. Okay. An example there, you have elements 2, 3. You have elements 2, 3. You have A is equal to 2, 3. So the symmetric relation R is equal to 2, 3, the pair 2, 3, and then the pair 3, 2. What is going to be in the domain here? If you drew the domain, 2, 3. And what is in the codomain? 3, 2. Okay? So you have elements, yeah? So you will have 2 going to 3, and then 3 going to 2. Okay? Then we talk about transitive relation. Transitive relation. Transitive relation. Transitive relation. Transitive relation. A relation R on a set A is called transitive if A, B pair is a subset of R and BC is a subset of R then AC is a subset of R. where A, B, C, where A, B, C are all subsets of that relation. Okay? So we have an example. You have set A is equal to 1, 2, 3. One, two, three. Then transitive relation R on A is, we'll have R on N. A is saying that you have 1, 2 as a pair. That mounts to 2, 3 as a pair. And then you have 1, 3 as a pair. That's an example of a transitive relation. Okay? Then we have an equivalence. An equivalence relation. I was thinking after oh, okay, maybe I'll finish the next topic. I'm going to give you a mock-up test. Now check others how they are looking. I'm just being a fair lecturer. You know, you don't want to make assumptions that you understand these things. Yeah? I'm as fair as God. Yeah? You know, we say God is good all the time. And all the time, but he will always, by the way, who tempts us? Do you tempt yourself? So not until you are tested, you can never know you are what. You understand what I mean? So these things here, they look like that. Now there are some students, I'm not saying that you are part of that, but because I'm using scientific means, I don't have to. Yeah? Because I'm using scientific methods of teaching, there are certain characteristics. Much as I've not calculated, I know that they are there. You know, science, the good thing with science, it doesn't lie. Now, for example, there are a group of students who are just looking at this. There are even people who don't have notes. You have seen today a student who was saying, hey, you mean we're in week? I saw somebody writing there. You have seen those who have been complaining, we are not having classes. Yeah? So I still have to reach to all those categories. But the best way is to give you a wake-up call. So I think after this, maybe I'll have functions. And then I'm going to give you, if I can finish this, we do functions next week. Possibly the other week, you do a mock-up test. Okay? Yeah? And what I do in the mock-up test, you can sometimes, you even mark yourself. That's the beauty about it. Just to give you an exam, standard exam, how it's going to look in your test. Then you start knowing that I'm either on the right direction or I'm on. And if you know what you'll have performed, still those things are going to come the way they are going to come in the test. Okay? So I want, by the time we are done with the test, yeah, even the one who has performed badly should not crucify. You will just go and say, in the name of God, I wanted to have that. Yeah? Because by the way, there are some students, even if you try as much as possible to make them pass, they will tell you, sir, you are not the one who paid my fees. You let me do my best. Now, those ones, what do you do for them? Yeah? Yeah? No. they will tell you that I did not come here to pass. Why do you think? Why are you imagining that you are just going to make? You're going to make me do what I don't want. So the equivalence relation. So we say a relation is an equivalent relation if it is three things. Number one, reflexive. Number two, symmetric. Oh, number three, transitive. Are we together? The condition for a relation to be equivalent or the equivalence is where the relation is reflexive, symmetric, and transitive. What do we mean by equivalence anyway, from English? Equivalence. Okay, in sets. When we're talking about equivalent sets.
There are sets that same number of elements but different types.
Same number of elements with different types. Okay? So now when we say an equivalence relation, okay, anyway, I think that is going to confuse. So now we are saying that for you to talk about an equivalence relation, it must have three properties. That set must be reflexive, and that set must be symmetric, and that set must be transitive. In other words, all the other above properties we have been talking about must exist. Okay? So you are going to be given a set and they ask you whether that set is equivalence. There, the reasoning, you will use figures to do the reasoning. You're not going to use the words to explain. You understand? Yeah? So, we have, for example, we have a relation R, which has elements. Can you describe for me the elements? Yeah? 1, 1. 2, 2. Yeah? 3, 3. 1, 2. 2, 1. 3, 2. 1, 3. We have skipped 2, 3. Here. 2, 3. Then 3, 2. Then 1, 3. Yeah? 3, 1. So when we talk about equivalence, don't start describing us now the English. Use mathematics to check out whether there is symmetric set in this relation. Check whether there is transitive set in this relation. And check whether you have, what is the other one? Yeah? You want to check symmetric, reflexive, and transitive properties in that relation. Then that relation will be equivalent. So when we ask you for equivalence here, don't start describing to us. Use mathematics to show the equivalence. So the question is, are you able to see a symmetric set or symmetric pairs in that relation? Okay, let's start reflexive. 1, 1, 2, 2, 3, 3. That is already reflexive. Are you able to see symmetric? 1, 2, 2, 1. Okay. Are you able to see transitive? Are you able to see transitive? Yeah? Transitive? Transitive relation? Go back. Hmm? Where you have 1, 2, 2, 3, and 1, 3. Okay? Now it is about finding out whether you have understood what the other three. They are very critical. Most of the exam questions I will mostly bring on, if it's, for example, on this relation, I will bring maybe proving an equivalence. Okay? Proving an equivalence. The good thing I've told you in time, so you won't say that this man, whatever he has brought. No, I never bring shocks to my students. But like I've told you, those ones who, I think those ones maybe who come late, those who dodge class, these things, as you can see, if you say that you are going there to say to revise, you can put your legs in water and burn midnight oil till morning. Yeah? Unless maybe for those who did submath. But all did submath. Isn't it compulsory at 11? Oh, okay. Yeah, so yeah. But if you have not and you said you want to depend, I'm going to ban books, my friend, you will ban books. Yeah? But it will be very tricky. So here you want to ban books after you have been given the minimum knowledge. Mm-hmm. We have, oh, you are. Okay. You need to support your friend. Eh? Eh? Yeah, maybe he will come and convince us after we are done with it. Hey, it's already 9 past. Okay, identity relation. Hey, there is first of all universal. I think you can read that one, can't you? Universal relation is a relation in which all elements of the set are mapped onto another element of the set. Then it's called a universal relation. Okay? All elements of the set are mapped to another element of the set. Okay? We have an example there. Identity relation is a relation defined such that all elements in a set are related to itself. 1, 1, 2, 2, 3, 3. But that almost looks like the reflexive. Yeah? Then inverse relation. A relation is called the inverse of any relation. If elements of one set are inverse pairs of another set, the inverse of the relation is denoted by R to that power -1, or to power, yes, to power -1. So if you had yx, then you get xy. You will find that also similar to another set up there. Okay. Now, in that still handout, there are those examples down there. I want you to go and do them. They are part of your assignment for this class. Solved examples. The good thing that, oh, okay, these ones are solved. Maybe I need to. Yeah, but anyway, I know still people will not. No, human beings were difficult, by the way. But I don't know why God, who loves us so much, also left us like that. Yeah? Our brains are very tricky. And they betray us all the time. And yet you are the one who is in control. You understand what I mean? Yeah? Our brains betray us all the time. Okay? Sometimes you can even do things and you ask yourself, is it me was just done? But you have actually. Then again, when the same problem comes, again you do it. You understand? And yet the brain is yours. Nobody has. You have free choice. Okay, so you do some of those questions, but just to make sure that maybe for those who might come later, I might just put for them some of those questions there. Okay. Any question? Yes. I've just said that they are similar, so they are the same. Yeah. Okay. Mr. Cavendish, come. Come here. You start practicing. In fact, as you come, you can, whether you are going to be bouncing, you need to support your own. Come and. By the way, the ticket is on. Hey, is it free for students?
Yes.
Oh, okay. Give us briefly what is going to take place on Friday. You want us to be there. What do we need to do to support you? 2 minutes.
Good morning.
Morning.
Hope you're feeling good. My name is Discrete Joel. I'm one of the members of the participation in this competitions. Please, members, be there. Students, it's for free. If you have friends that you can bring over, that case is handicaping that is communication. Please support me. If you see the link, see the name, you will see the Joel. It starts with A. That's my name. Please support me. You hear me, that's it.
Okay. All right. So, I will personally be there. I will personally be there. That's on Friday, 21st. Yeah, it is this Friday. Yeah, but we want you to come physically. Those who will not, my company will be sponsoring streaming. Okay? How many of you by there have subscribed on my platform? Oh, I've never told. Tanya Innovations. Oh, okay. Now you go to YouTube. Oh, I don't know how I forgot that. Part of the work that I do global business networking, I do business trainings, I have shows, monthly shows called Global Talk Shows, okay? So if you're a person who wants to learn what is happening around the world, listening to experts from different business circles, just get there. So you just go on YouTube, type in Tanya Innovations Africa. Okay? Subscribe, make some nice comments. Bad comments, please keep them to yourself. Okay? But if I have, how many number here? If I have 60 of you subscribing in the next 5 minutes, that would be very powerful. It's value for money. This is not, if you are coming there for entertainment, please forget. Mine is transformative. Okay? Those, sometimes people have asked me, hey, why do you host people from, I don't know, I select my guests very carefully. Yeah? Not picking for you, who? For you, what was this man who died? The MP who died. Like people who are comic, eh? I know that people are like comedy, but that's not my style. Eh? My style, I'm very serious because I need to transform some minds at least. So we have quite a number of, I think we now have about, we have hosted about 60 shows now, okay? Including your chancellor. Do you know your chancellor? My friend. Do you know that you have a full former head of state as your chancellor?
Yes.
Yeah? The chancellor of this university is His Excellency Jonathan Ebele Goodluck. And he comes here, by the way, every graduation to pass out. So if you have never heard His Excellency Jonathan Goodluck speaking, go and listen to his story. Get onto that platform, you'll get an interview that we had with him. You never know, his story might encourage one or two for those who are in leadership. Okay? Others are business related courses. The last one we had, we hosted a lady from Mississippi. The top 50 the top 50 most important women or strong women from Mississippi. She was talking about strategic management. I know some of you will say now, strategic management, sir, me, I need things about the job. My friend, that is where you're going. Get into the corporate world, learn how the world is moving. Yeah? Okay. Yeah, you can also visit my LinkedIn. I usually make a number of postings, either whether there are business opportunities, or sometimes I talk about certain trending topical issues, but that is on Maganda Evans studying work. Okay? Now, we encourage, by the way, I do encourage students to have online presence. Do you know what it means? I've had so many students, by the way, going to the UK, they have finished their course, then they want to be recommended. And they want to start with writing a letter, and there is nothing, even a single post they have made, like for example, on LinkedIn. Forget about TikTok, because TikTok, they will find you, but whatever you have posted there sometimes will be the killer of you. Some of you are careless. You are just thinking about your small groups of. So be very conscious that today, you, the person you said you, the one that people will look for first, before they even come for your details, will be that person online. So at this level, as you get into professional scale, start limiting certain posts. Okay? Because they will hold you somewhere. We will go for an interview for you, and they're, hey, my papers. Hey, you enter there, but people have files like this about you. Okay? So even if you are planning to come and do your dance online, do it with the purpose, knowing that the audience is there. Don't just come there as if you're a guara from a village. Yeah. Okay. Okay, that's it. Have a good day. We shall link up and meet. Okay, those who will do whatever on Friday. So we are going to create a link for that event. Some of you who want to whatever, please. Okay. If you also have people that are in things to do with technological innovations, interested, let them also. You can be able to share that platform. Okay. Okay. Online, do we have any question? Okay. Oh, Oyoga Martin, you have subscribed. I'm hearing Kakuru Ngoma. What were you saying? Kakuru. Selina. Okay. Okay. I'll leave you till next week.
Sorry.
Hello? Kakuru, I saw your posting in the chat. I was wondering what you what you are talking about.